Mathletes, what we're going to look at in this video is we're going to go to polygons. So we're going to go to shapes with, you know, more than, well, including three sides, 4 sides, 5 sides, so on and so forth. Okay, so in the last lesson, we were talking about our friend the triangle, which is technically a polygon. So we're just going to extend that. So we're just going to keep on moving. Okay, what I like about this lesson is it's a little bit, to me, easier to see than the other ones you've been doing with proofs and parallel lines and transversal and, vertically opposite and alternate interior. I find this one a little bit easier. So our goal here is to learn about angles in polygons, see if we can make some general rules. Okay, so again, some more definitions that you're going to want to put together. So a regular polygon is when all angles are equal and all sides are equal. Okay, well, friends, I'll give you the most easiest case. An equilateral triangle. So in an equilateral triangle, all sides are the same and all angles are the same. That's all it means. And I could do a square, I could do a pentagon and a hexagon and a dodecahedron or whatever. All angles are equal and the same. So that's what the word regular means. Okay, irregular means not all angles and not all sides are equal. So if I go back and I think of a triangle, well, I'm just going to make some crazy scalene triangle like that. Now nothing's equal in there. So that's an irregular, when not everything is congruent or the same. All right, that's an easy definition to know, right? Okay, so now we're going to talk about convex and concave. Okay, how I think of the word convex and concave is I think of my soup spoon. And now don't laugh at me, I can't draw. It's as good as it gets for me, right? There's my spoon. That's just horrendous. Okay, the part where I catch my milk when I'm eating my corn pops in the morning, that's the concave part. And the part on the outside here where I don't catch my milk is the convex side. So same idea here with polygons. So a convex polygon is something like this, meaning that if I were to pour milk on it, I wouldn't catch anything, just like on my soup spoon over here, my milk spoon, I wouldn't catch anything. So that's how I think of it. So if I poured water on top of this rectangle, or if I poured water on top of this triangle, or if I poured water on top of this parallelogram, I wouldn't catch any of my milk. So it's convex. What the proper definition of that is that all interior angles will be less than 180. Okay? Concave then, well, I'm going to think of concave as I'm catching my milk. So it means there's got to be some kind of crazy shape where I can catch my milk. So the milk would land in there. So that's concave. Okay. You can draw these things any way you want to draw them. Like they're crazy looking shapes. And so what I know for sure is that one of the angles somewhere has to be greater than 180. Okay. But how I think of it is here, it appears there's a dent in them. It means I can catch my milk. Okay. So let's go see if we can do some work with these things. They're actually pretty easy to work with. Okay, so the first thing we want to figure out here is, what do we know about the sum of the interior angles of a convex polygon? Okay, now normally there's an investigation you can do in the lesson and figure it out on your own. Okay, for the sake of time, I'm simply going to give you the formula here. So the sum of the measures, so of adding up all of the angles, so all angles, the sum of the interior angles, sum angles interior, is equal to 180 n minus 2, where n is the number of sides. Okay, so if I want to think about this for a second, if I had a triangle, I would say the triangle has 3 sides. So I would say 180, 3 minus 2. Well, 3 minus 2 is 1, that's 180. Yeah, sure enough, I know my triangle. The interior angles have to add to 180. Okay, so let's try this. This is actually a really easy fact to work with. So determine the sum of the measures of the interior angles of a decagon. So the only thing we really need to know here is that that's got 10 sides. So that means n is equal to 10. So the sum of the interior angles then is 180, 10 minus 2, which is 180 times 8. Make sure you got that degree symbol in there, which is 1440 degrees. Okay, that's the sum of all of the angles. But then the next question says, determine the measure of each interior angle. So I don't want the sum. I want how much each angle's worth. Okay, well, pentagon, that's 5 sides. So I find the sum of all my angles. So it's helps if you can write the formula down properly. Try that again. So 180, n minus 2, 180, 5 minus 2, 180 times 3, and that's 540. Okay, but that's the sum of all the angles. Sum all interior angles. So how do I find the measure of just of each interior angle? Well, if I know the sum total of all of them, what I'm going to do is I'm going to take the total and I'm going to divide it by the number of sides. And that will give me each individual side. Individual angle, I should say. So each individual angle, well, the sum total is 540. And there's 5 sides in a pentagon. So what's that? That's going to give us 108 degrees per angle. Okay. Now there is a formula that goes along with this, and if you want to write it down, you could create it. So essentially, if you want any individual interior angle, you would go 180 n minus 2 over the number of sides. Okay. I don't have that formula memorized unless I'm doing the question. All I really need to know is this one. Okay, but if you want to use it, it's on your formula sheet. All right, let's try another one here. So this one says, what would the total sum of the interior degrees measure be for a 14-sided polygon? I have no idea what the name of a 14-sided polygon is. Okay, what would the measure of each interior angle be? Okay, perfect. So this is really just us putting it together. Okay, so the sum of all angles, all interior angles, is equal to 180 n minus 2, 180, 14 minus 2 because it's got 14 sides, 180 times 12, and 180 times 12 is 2,160 degrees. Okay, that's the sum of all interior angles. Okay, what is each individual angle? So individual angle. Interior, I should say, to be precise, is the total divided by how many sides? Just like that. And we get 154. So, I mean, it's an easy fact to remember. Okay, so you just need to know this one, friends. And if you forget, I always go back to a triangle. That's what I always think about. Okay, last one. The sum, they're giving us the total of the interior angles is 2520. How many? Determine the number of sides. Okay, so what we're looking for in this one is we're looking for n. So I write down my formula. The sum of the interior angles is equal to 180 times n minus 2. Well, the sum is 2520 is what it tells us. And we've got to find n. Okay, so what I'm going to do is I'm going to divide both sides by 180. And I have to grab a calculator for that one. 2520 divided by 180, 14. And now solve for n. N is equal to 16. So this polygon has 16 sides. Okay, so this one, like I said, I think this lesson is a little easier than the last one. You just got to really know this formula, and you got to know the definition of regular and irregular polygons. And that's about it, convex and concave.